participants of the webinar, colleagues, friends. We are beginning our second webinar dedicated to the cycle of experiments and studies which we are conducting upon the order of the regional gas company. And I hope that we shall continue this series of webinars. I want to apologize at once for certain imperfections, so to say, of our first webinar. Those have been very scientific reports, presentations, and unfortunately, not all the participants, not all the attendants are to the level of the topic. We took into account those drawbacks, and we tried to make our second webinar more interesting and more broad information, like for to be more convenient for the listeners, and you would assess it. And now I want to give the floor to the driver of the project. I repeat it, to the head of this project from regional gas company, the person who conducts webinars meetings once 2 weeks, and to set up and to arrange all the experiments, to have all the experiments to the schedule and have the efficient result of the experiments. Stanislav Kazda, you have the floor, please. I welcome all the colleagues, all the participants of our second webinar meeting. It is the second one, and we really hope to continue these webinars. And I thank the colleagues from Naftogaz Informatica who are organizing all this for us. I want to say that the experiments which we already completed have their results, and we have rather large scale testing of different type of materials, and we shall have the opportunity in the nearest future to assess different materials of the plastic pipe, metal pipe, etc. And there is a news. We are close to sign to conclude the agreements on on the sealant materials experiments, and we shall start them in the nearest future. I thank all of you for your participation, and I give the floor to the speakers for them to deliver to you the latest information. Thank you, Mr. Stanislav. Before giving the floor to the speakers, I have just few comments on the problematic issues. Eventually, many participants of the webinar do know already that we have a renaissance of hydrogen topics. In the beginning of 2000 of this century, there was much interest on this. Some studies, some papers, some articles were published. Everybody said it is our future, but unfortunately, it finished all on that because the relevant decisions haven't been taken. The economic parameters were not to the level, and also the safety parameters presented some problems, all regarding use of hydrogen. Now, currently, as I believe, and as the participants of the experiments believe, we are already on much higher level of technical and scientific development. Moreover, the economic parameters, meaning the expenses for renewable energy creation, are being shrinked, are much less than before, maybe tenfold. And we hope to achieve satisfying prospective economic results for the future. And this time, this renaissance of hydrogen energy will develop, will continue, will not go down. As an example, I want to give you some illustrative element. We do analyze the transport of hydrogen and natural gas mixture through the system of gas distribution pipelines. But the scientists who participate in our experiments are dealing not only with those problems. For example, the Institute of Gas of the National Academy of Science of Ukraine created some installation which is successfully splitting the natural gas on hydrogen and the carbon residue, which is as concentrated carbon. It is a complicated process, but we have to congratulate the Institute of Gas for having such positive results. So we are dealing with these experiments on distribution, but the consortium created covers much broader aspects of hydrogen economics. And now I want to give the floor to the Doctor of Technical Sciences, the Prorector of National Institute for Oil and Gas, as I believe the youngest Prorector of Ukrainian high schools, Mr. Maxim Karpash. Mr. Karpash, you have the floor. Hello, everybody. I I'm trying to share my presentation, to share my screen. Let's try once more. Maybe let us start with the video. Meanwhile, I am trying to adjust screen sharing. Yes, let us do so. I want to tell what is topical and what is very interesting. The university started to began to teach students the aspects of hydrogen economy. It is very reasonable and it's good perspective for the future. And now we shall watch the video on how the students are being educated, trained exactly on that aspect of hydrogen economy. The state enterprise Ivano-Frankivsk Standard Metrology conducts a series of experimental studies to identify the impact of hydrogen and hydrogen gas mixtures on the operation and change of meteorological characteristics of domestic gas meters. In accordance with the first stage, a method for conducting experimental researches was developed, and a study of meteorological parameters of gas meters in laboratory conditions at laboratory installation using the air as a working media were conducted. In the second stage of research, a series of scientific tests to detect the impact of hydrogen on the tightness of gas meters is being conducted. An experimental installation has been developed to study the effect of hydrogen. I want to apologize. This video was to serve for the third point of our today's webinar. Yes, I'm sorry, I am already managed to share my presentation. Can you see well my presentation, colleagues? My presentation, my report will consist from two sides, from two parts. And the one part will consist of the scientific results. We have been participants to a scientific consortium, to a scientific group working under the auspices of Naftogaz Bud Informatica on the topic the possibilities of testing and of using the gas and hydrogen, natural gas and hydrogen mixtures in some uh, sites of pipelines. So my presentation contains some extracts, some excerpts from those results. Also, they are much larger and much more voluminous. So we had a task to see how much the existing gas pipelines are ready to transport hydrogen and natural gas mixtures. also to assess the sealants, the issues of safety, etc., and to think where could we move ahead in the sense of studies. I will not talk a lot about the method itself. Actually, we saw that there is no serious normative documents, some regulations regarding, so to say, civil use of hydrogen. They are there, obviously, in some sectors of energy and chemical production, but not so many of them in a more broad sense engineering understanding. I'm talking about the regulatory normative documents, and it was a challenge for us. When we developed the methods, we looked at the scientific progress, as it was said, the renaissance of hydrogen topic. It is accompanied by a huge number of innovations appearing. It was interesting to see for us that the indicator test strips to detect the micro leakages of hydrogen exist already. They are changing their color from almost white transparent one to the coal like color to black color. When there is a critical concentration of hydrogen in the air, it is very important because the molecule of hydrogen is very small and it's very difficult to detect it with some indicators, especially at open air. So for issues of tightness testing, it was a unique innovation for this method. Obviously, we used also the manometric classic method of tightness control, and we calculated how the pressure was dropping in percentage over time. We used also gas analyzers, and we also decided to prohibit using the flat face flanges, which are very common. And we conducted our mathematical simulation calculations, and our calculations were very much correlated to the actual measured parameters, measured values, depending upon the pressure and temperature. Also, we conducted mathematic simulation modeling of possible explosion danger and the consequences of such explosion of the gas and hydrogen mixture. We saw that with the weight of hydrogen of up to 4 kilograms, the risks are not so high. There is very low probability of some event, of some negative impact resulting in injury of human health and life and properties. Those have been our initial results on 5 points assessment in 5 test sites on tightness loss and pressure drop. There have been problems because these test sites were imitating the actual condition of our gas pipelines. We understand that the condition for tightness is not perfect there. These graphs show also the simulation of those processes. Also, we have seen that if we have some vessel completely filled with hydrogen, and Mr. Stanislav was very right, proposing us to move from the river. So we began from trying 100% hydrogen filling of certain sites, and we saw a very unusual temperature impact, which is not proper for natural gas. In the summer, we saw a very strong impact of temperature and daily temperature fluctuation on those test sites. What does it mean? Thanks to temperature impact, we could not see, we could miss the manometric pressure changes. They were masked by these temperature changes, and it was complicating the processing of the data, of the results for us. And we saw the whole picture only on a 2 weeks time frame. On a longer one, talking about temperature impact, we have to consider it at the level of metrology. We have to study to monitor it more in detail. And at the level of the reports today, it remains a challenge for everybody. I mean, the temperature fluctuation impact. Talking about the technical readiness of our gas networks, I believe they are not ready as they are now. They require additional investments to change something. and everybody understands it. And obviously, there is a myth talking about huge risks of explosion of hydrogen, etc., etc. So those myths are not confirmed by the calculation, but the calculation are rather reliable. I believe we have to believe those calculations. In the next steps of studies, we worked with the methods for what was already announced by my colleagues, the impact of hydrogen on the quality of tightness, on node by node study of different metering points and connections. Micro leakages should be also studied in the next stages. Also, it's very important to assess the risks for population because the results of that risk assessment will influence the calculation and mm, design of the parameters for safety areas around the pipelines. And the results show that the best concentration is 23%. It is already fixed in the European Union. At the next steps, we as a university look broader. We have to think not only about low pressure and medium pressure, we have to also pass to high pressure to main pipelines. Latest news, European Union regards and considers Ukraine as the largest supplier of hydrogen, the second one after Africa. So we have to think about hydrogen, green hydrogen produced from renewable sources. In our part of Ukraine, in the western part, the railway connection is an acute problem in Chernivtsi Oblast. In our oblast, the railway hasn't been yet electrified. So from the point of view of environmental protection, we could switch to hydrogen transport, to hydrogen as a fuel for the railway. And there is a lack of specific knowledge in this hydrogen area. We did already something to cover that, and we'll show you the video. And also talking about the development of normative documents which are being created. The regulatory framework has to be adjusted. It is also a great issue to be discussed and to be worked on. We also have the relevant equipment in our university where we are teaching students and where we are showing them. This is a small installation, water electrolyzer and a kind of a small closed cycle of hydrogen production and use. So let us switch on the video. I welcome everybody. I am Andrei Yuvorsky. I'm the teaching professor of the chair for diagnostics and metering of Ivano-Frankivsk University, Technical University of Oil and Gas. We are now in the laboratory for studying the renewable energy sources, where we begin basic education of renewable energy engineers. Here we provide the main notions, main terms on solar, wind, bioenergy, use of hydrogen as well. Hydrogen is as a fuel of future. And I would like to talk a few words about hydrogen. Accordingly, in the edu curricula, we have the possibility to show the students a complete cycle of hydrogen energy and mainly the generation of green hydrogen, storage of hydrogen, and use of hydrogen. So a few words about what can we show our students in our lab. For production, for generation of hydrogen, we have electrolyzer. To obtain this energy carriers, the hydrogen, this device just needs distilled water and electric power. In this case, we take the electric power from the main power network, but this model also allows to be connected to energy sources produced by wind or by the sun. For example, I can use such a photovoltaic panel to power this electrolyzer, which produces in its turn the hydrogen. Now comes the question about storage of obtained hydrogen. Accordingly, we do store the hydrogen generated by from obtained from water in such a vessel. It's not just a vessel, it is the result of high technology. In such a small vessel, I can store up to 10 liters of hydrogen under the pressure of 30 atmospheres. Accordingly, this vessel, as I already mentioned, it is not just a metal envelope. Inside this vessel, we do have the metal hydride, the compound of nickel and lanthanum, and it allows in the most efficient way to absorb and to keep, to store hydrogen. In this case, the atomic hydrogen is being absorbed. In this way, when we shall connect to this storage some consumption, we shall have at the exit the pure hydrogen with 3 9 degrees of purity. That is how I can store hydrogen here. And also this vessel can be transported. Thereby we do transport hydrogen. Now let us pass to the third stage. How can we transform this accumulated, this stored hydrogen back to energy, hydrogen to power? In this sense, we understand perfectly that we can use the classic way by just burning it banally, but we understand that this way is not very much efficient, but most efficient and convenient way for us is a direct transformation or conversion of hydrogen into electric energy. How can we do it? We do use for this the device which has the name fuel cell. The fuel cells are metal polymeric devices which allow us to transform the accumulated hydrogen and the oxygen from the air into electric energy, into the power, and we then can use that electric energy, that power. Let us see how it works on our device. We connect our hydrogen bottle to the system, and the compressed hydrogen through the reducing valve is supplied, is fed into fuel cells. We open the feed of hydrogen, and the hydrogen passes through the system, as you can see. And now let's connect to our chain of fuel cells, to, let's say to battery of fuel cells, some load. Let us use the electric motor as a load. As you see, our electric motor is working, is moving. We have no batteries, no other sources of power here, except for the only one source, which are fuel cells. The hydrogen is obtained from the water and from this bottle, and the oxygen is taken from the air. This technology is absolutely neutral. It is zero emission technology because we obtain electric power here, and additionally to that, due to the fuel cells reactions, there is just water steam. Additionally, in the process of water and oxygen transformation in this fuel cell, we also get heat. It is also another great advantage of. So in this chain of production, storage, and transformation to power of hydrogen is a completely modern technology in line with all the requirements of energy transition. That's how we can say that the future belongs to hydrogen. That is how, by wrapping up, I want to complete my this part of my presentation. It is very interesting for us to conduct the studies. We really believe that the future belongs to hydrogen. It will be used not only to be distributed through gas networks, it will be used much broader. So we are ready to conduct more of such of the relevant experiments. like those we shared with you right now. We thank Maxim. We thank our participants from Ivano-Frankivsk National University. I want to support Maxim when he was talking about gas distribution, gas transportation system, talking about the main power, main pipelines, main gas pipelines. Our consortium conducts many studies, many testing for distribution networks, and the results of those studies can be used for main gas pipelines. And it will bring a lot of savings in terms of money, and also will help to complete the task setup and mainly to cope with the opportunities on transporting certain amount of gas and hydrogen mixture through using our main pipeline system to transport them into European countries. Now I want to give the floor to Doctor of Technical Sciences, the head of gas of a sector in Gas Institute, Mr. Pianich. He participated in the first stage of hydrogen tests and also in this second stage of test in Ivano-Frankivsk. I will not tell you what was analyzed. Mr. Konstantin, please, you have the floor. Thank you. You know, after the presentation of using hydrogen in fuel cells, I'm coming back to its use just to burn in the boilers. I'm feeling myself closer to some primitive methods. But anyway, what we are doing, I believe it's some transition period, which should be durable because we have all the systems which are functioning and they have been designed for use of natural gas. So we cannot switch just of in one moment. So we have to check how the existing equipment works on the mixtures of natural gas and hydrogen to check whether it is safe or no, whether it's environmental or no, what problems could arise there. It is not a forecast, it is a real assessment of the situation. So our task will conduct the so-called I'm coming back to my presentation about the parameters. The temperature of combustion products. Rodamic temperature change range is 50 to 140, and now I will share a presentation to show you the relevant ranges of temperature change on three different boilers. You can see this graphs now. Yeah, it's okay. Combustion products temperature. That's what we are losing with the flow gases. In Rodamicra, it is 80, 140, Optimus 40, 120, Jitomergy just 20 to 80. Another specific difference in the boilers. In the modern boilers, all the air necessary for the combustion comes to the both to the boiler and to the burner. For Jitomer 3, for the old design, boilers, the following scheme is characteristic. A part of air is submitted to the burner in the boiler, and then at the flue pipe, there is a hole through which the air from the room comes to the flue pipe and is mixed to with combustion products, thereby reducing the total temperature. And there is some real situation on that the excess air in the boiler and in the flue pipe are different. But so with this boiler, you cannot detect, you cannot measure exactly the temperature, the output temperature due to this. Another point, dependence from combustion temperature. This is the temperature of fuel gases at the output and the consumption of air. This is a typical situation for both modern boilers. The temperature 140, the volume of air 50, 60. That's what about exactly I mentioned. There's a reverse ratio, reverse relation from that one which should be there. And this picture, there was a mistake in the title. It is not rhodamic, right? It's determiner 3. You see the temperature is 20, 40, and there is a relevant increase of flue gas temperature. And I already mentioned about this boiler, this old type boiler with increase of hydrogen share. They collect some of the condensation, not all of it, because the boiler doesn't allow for that. You see, for highest hydrogen share in the mixture, there are 300 grams of condensate per hour, which are formed there when burning the mixture of hydrogen and gas. It is good for energy parameters, but not good for the operation of the equipment. It is not acceptable because the boiler will be destroyed very quick. But you see, with 30, 20%, and even with 10%, we have some condensation, because the temperatures are too low. Talking about the use of boilers, we have to take into account this problem. Condensate can be created, so we have to create a circulation system existing in large boiler rooms. So to prevent from the temperature, so to provide for that the temperature of water is heated in the boiler to be higher than the temperature of the steams. The environmental parameters. There is CO, obviously, emitted. Obviously, a higher hydrogen share results in lower CO in combustion products. All the boilers are good in that sense, but the thermometry has reverse parameters because the old equipment is 50, 30, 40 ppm. It was recalculated for 3%. These parameters I believe to be standard. It's rather high quality about environmental parameters. Talking about nitrogen oxides, here we have different results. Talking about theory, the use of hydrogen results in increase of temperature and thereby increase in formation in appearance of nitrogen oxides. But the tests show that this relation is not very linear. It is a sophisticated relation. And in the discussion, it was said that from this point of view, the hydrogen brings into the a great number of water, like vapors, which reduces temperature and reduces the formation of nitrogen oxides. Talking about environmental and energy parameters, use of hydrogen doesn't result in significant reduction of efficiency. Talking about e- even if you look at the natural gas, talking about regulated air inflow, it will even result in the increased efficiency ratio for combustion of the mixture and will improve the parameters, energy parameters of a boiler, even when using only natural gas. So our test showed that such a modification would be necessary. Talking about nitrogen oxides, you see in most cases, in most situations, the use of hydrogen improves environmental situation significantly. And now I want to talk to you about problems. Maybe somebody will suggest us how to cope with them. We tried to use convector. A convector heater is where gas is just burning and the convector is heated by this process of gas burning and passes the heat to the room by convection. Here, all our testings before they were made from achieving a stable regime, then measuring the situation, assessing it, that's all. But the convectors are not designed to work on stable regime. They work while the gas is submitted. The gas is heating the convector plates material to the panel is the temperature is set up on the panel, so the convector is working up to achieving the setup temperature, which happens after 2 to 3 minutes after the burner has been worked. But it is not a stable mode. The temperature is increasing little by little. So to start the work, we submitted natural gas in the amount of zero point 0.3 cube per hour. But in 5 minutes, you see how the temperature increased. 130, 140 are the temperatures of side panels, and 214 is the temperature of a top panel. And now the device was hidden from all over, and it stopped working. We stopped the device and tried to solve that problem, but we haven't found a solution because this equipment is not working, is not coming to a stable mode of operation. We tried to test to measure it in the mode measure immediately after launch, but gas metering takes time. Temperature metering also takes time, and so it is not very accurate. The equipment works without errors in this mode. It works. It operates properly. Nothing else can be said because you see these parameters, these values measured by us when we launch this device and we measure outflow gases temperature for a couple of minutes. You see the temperature of burning is 250. This equipment is believed to be modern. It is one of the best variants of the equipment of the convector. And now let us see what it goes about. You see the launch is a consumption of 0.66 cubes per minute, 50% of hydrogen, 50% of methane. We launched it and we have got the result 144. You see the middle column. In 1 minute, the temperature was 1.44, and then it goes down, down, and as a result, the torch is dropping, and there is a high emission of CO and other volatile pollutants, and the process stops. Maybe somebody could suggest us how to analyze it, because I believe testing such kind of convector is important because we have many of such equipment in the use. But there is no way to test it into a stable mode. So I thank you for your attention, and eventually it would be nice to hear from you some suggestions, some hints how to cope with this problem of non-stably working connectors. Thank you. Thank you, Mr. Konstantin. You also touched another issue. And this is a question to the participants of the webinar. The answer to this question, where should they address the information, questions, suggestions? We have our email address. Please send all your proposals, your point views to our email address. I promise you to answer all of your questions. That is nafta, gas, food informatica, etc. And now we switch to the third component of our webinar, that is the metrology. Before watching the video, I want to tell you that what has been done up to now. The method for studying the impact of pure hydrogen and the mixture on the metrological parameters of gas meters used in the domestic sector were developed. The metrologic parameters of membrane type and rotor type gas meters have been studied in the number in a rather big amount. Many of those meters were used in the laboratory conditions. And now the process of saturation with hydrogen of those meters is continuing. And now let's watch the video talking about this experiment. State enterprise Ivano-Frankivsk Standard Metrology conducts a series of experimental studies to identify the impact of hydrogen and hydrogen gas mixtures on the operation and change of metrological characteristics of domestic gas meters. In accordance with the first stage, a method of conducting experimental research was developed, and the study of metrological characteristics of gas meters at a laboratory installation in the laboratory using the air as vacuum media were developed. In the second stage of research, a series of static tests to detect the effect of hydrogen on the tightness of gas meters was conducted. Currently, an experimental setup has been developed to study the effect of hydrogen on different types of gas meter connections, with a possibility for detecting possible hydrogen saturation of various structural elements and conducting experimental studies. According to the method, gas meters are filled with hydrogen at low pressure, and experimental studies are carried out for 42 days to detect the tightness of gas meters under the impact of hydrogen. To conduct the study, the meters are filled from a cylinder of pure hydrogen to low excess pressure. And the pressure is monitored using an U-like manometer with a water valve to prevent dissolution of hydrogen. The unit is gradually filled, the meters are connected in parallel, after which the values of excess pressure are recorded and the values of pressure are taken daily. The tests are performed for 42 days. As I understand, the video is over, and basically we passed the whole program of our today's webinar. I want to tell you that the meteorological tests have just begun, and during our next webinar, we shall consider certain results, the first results of this part of the meteorological test. I want to tell you at once what do we plan to consider and to study on this third webinar. Mr. Stanislav Kazda already mentioned about it. It goes about the organization of testing of filling with hydrogen the metal pipes and the polypropylene or plastic pipes. Eventually, some other novelties will appear and some news will appear, which will deliver to the listeners, to the participants of webinars. Taking this opportunity, I want to tell you that on the 28th October of this year, we shall conduct the next Ukrainian Gas Forum, the seventh Ukrainian Gas Forum. Its name is Seventh Ukrainian Gas Forum, East European Gas Hub, the Green Deal East European Initiative. We are now preparing the panels, and the speakers, facilitators will be selected by international organization committee made up by the representatives of consulting structures, companies, energy associations from Ukraine, Europe, Russia, and from Northern America. In the nearest time, we plan already to provide a program, an agenda of this forum to hear from you your proposals and about it. We shall distribute it in Facebook. And now I want to ask Mr. Tata. Yes, I do hear you. I want to thanks to everybody who helped us to prepare today's webinar. I hope there was enough information. Information would all the listeners, and obviously I do invite you to next webinars, which we do plan. If everything goes to the plan, then we shall also submit rather big volume information on the forum, on the guest forum, 28th of October. So I invite everybody to participate in that event, which is planned. And we shall share with you certain new information, certain separate results of our experiments. Thank you for your attention, and see you on the next and wait for you during our next webinar. Thank everybody for participation.